Hi, kids!
I am going to do a little vector practice with you guys. Make sure you're okay. So this is my little physics vector thing-a-ding. I'll go through a vector addition problem. Make sure you guys are okay. So let's say we have a problem that looks like this. You walk 5 meters east, and then you walk 10 meters south, and then the question asks you, number one, what's the distance you travel, and then number two, what is your displacement? Okay, so first of all, okay, if there's a question that says, hey, you walk 5 meters and then you walk 10 meters, and what's the distance you go, don't get it wrong. Like, everybody should know that. Well, 5 plus 10, you walked 15 meters, okay? Like, make sure you guys don't get that wrong, okay? But the displacement one, remember, this is how far you end up from your starting point. So I'm going to draw it out over here so you can see. I'm going to make it nice and big. So you want to draw your F and arrows. So let's draw our F and arrows. So first, if I wanted to say, hey, I am going to walk 5 meters east, and then I am going to walk 10 meters south, you will notice a couple things. Number one, I drew arrows. If you don't draw arrows, you don't know if you are putting them tip to tail. Because remember, to add vectors, you have to add them tip to tail. Number two, I made the 10-meter one, at least I tried to make it twice as long as the 5-meter one. Why? Because 10 is twice as big as 5. So there you have it. So now, okay, again, your displacement is like the final direction, guys. Please don't screw this up. Like if I walk east and then south, I am going to end up southeast of my starting point. Duh. But here's what happens. I have some students that go, I'm just going to memorize because I don't want to think, so I'm just going to memorize, and they memorize tip the tail, tip the tail, tip the tail, and they don't think about anything. And because they don't think about anything, when they draw in the resultant, they draw it this way. So they draw it going the wrong way. And that doesn't make any sense because here's what you are saying. You walk east, you walk south, and somehow magically you ended up northwest. Not going to happen. So make sure that you draw it correctly. It should go from the start, okay, to the finish. And hopefully you can see that okay. How about if I move this a little closer so you can see it better? All right, so there you go. But it should go point this way. It should have an arrow on it. Why? Because the resultant is a vector. So it has an arrow. It's going to point that way. Dot, 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 dot. All right, so far so good. Some people might ask, well, geez, Lindenberger, you said tip the tail, tip to tail, tip to tail. Yes, but I said when you add vectors, you add them tip to tail. And if you notice, I am adding the blue vector and the red vector, and they are tip to tail. I am not adding the green and the red or the green and the blue. They don't need to be tip to tail, okay? Use your brain. If you went this way, it would work equally fine. So if you did this, no problemo, and then your resultant would still point from the start to the finish. It'd still point southeast, okay? But now we need to figure out how big this vector is, because all vectors have magnitude and direction. So this is where you're going to use your handy-dandy calculator and Pythagorean theorem. 5 squared plus 10 squared equals, and then you take the square root of that. I do not want, guys, give me an actual number, and you get 11.18. So I get 11.18 meters. Okay, but I'm not done because this is a vector, and vectors require you to have direction. And you can't just say southeast because that's not specific enough, so you need the angle. Now remember, this vector is going this way. To name that vector, I want this. So the other way you can remember is take the one that touches the horizontal, this one, or if you like, it's going to be the same as this one because really it's that one, alternate to your angles. Okay? So I'm looking for this angle. Now, to find that angle, you guys have to use your mad trig skills. Okay? I don't care, guys, if you do sine, cosine, tangent, cosecant, whatever, law of sines, law of cosines, whatever. Okay? I'm going to do sine. Why? Because that's my favorite trig function. If I'm going to cuddle up with a trig function, it's going to be sine. So I want to show you. Sine is so, which stands for opposite over hypotenuse. So I'm going to say sine of the angle equals opposite over a hypotenuse. So there you go. And if I do this, okay, if I take 10 divided by 11.18, I get that number, okay? So I get sine theta equals that number, 0.894, okay? So I need to solve for theta. So let me show you what to do, okay? I'm going to hit second, and then I'm going to hit the sine button. And when you do that, you will see sine to the -1 comes up. And then I'm just going to hit answer so that it just takes my last answer, and I hit enter. And lo and behold, I get 63.4 degrees. So my final answer to answer this question for displacement would be 11.18 meters at 60, what did I say? 63.4 degrees south of east. All right. I hope that helps. Bye, kids.